Good morning, everybody. Happy Tuesday. Jumping into another video about slope today. And in this one, we're going to look at a slope formula that can be pretty useful. So with that said, let's jump into today's lesson. Alrighty, here we are, page 529. And we're going to take a look at the slope formula. So we've calculated slope using just rise over run, where I'm actually looking at a graph. And what we're going to do today is switch that up a little bit and actually use a formula. So to start, quick little review. Complete the following statements. The slope is the measure of the steepness of the line. How hard would this thing be to walk up or down? Okay. Slope is the ratio of vertical change, called the rise, over the horizontal change, called the run. Slope equals rise over run. A line segment which rises from left to right has a positive slope. And the opposite of that, if it falls or if it goes downwards, it has a negative slope. A horizontal line segment has a slope of 0. A vertical line segment has an undefined slope. And that was because we can't divide by 0. I have no run and I can't divide by 0. The slopes of all line segments on a line are equal or the same. Okay, which is if I have a line, take any 2 points on that line, find the slope, and you just found the slope for the whole thing. Okay, let's take a look at the slope formula. That's what we're actually going to look at today. Yeah, we'll figure it out from there. So it says calculate the slope of line segment AB using rise over run. Slope equals rise over run equals. All right, well, I'm going up. So positive rise 1, 2, 3. And I'm running 1, 2, 3, 4, 5, 6. So what was that? 3 over 6? Yeah. Or reduce that fraction to 1/2. Okay, up 3 over 6. Slope 1/2. Well, now let's actually talk about those endpoints. Let's talk about those coordinates. Okay, A is the point 1, 8. And then B is the point 7, 11. Hey, 7, 11. How can the rise of the line segment be determined using the y from point B and the y from point A? Okay, well, my rise was 3, and those values would be 11 and 8. So you're kind of thinking, how could I get 3 from 11 and 8? And if I think about it, what I'm really asking myself is, from A to B, what is the vertical distance? I actually don't care how far I went over. When it comes to finding the rise, really what you're saying is, what is the difference between the y points? So that's what you did. YB minus YA. Okay, so this is rise equals 11 minus 8, which gave me that number 3. And that's what I found the rise to be up here. Okay, so it was take the y value from the kind of the far point, take the y value from the close point, and find the difference. What actually is my rise? And then for x's, it's the same thing. What is my horizontal difference? We'll take the horizontal value over here, horizontal value over here, or when I say horizontal, what I mean is x. So the run would be the x from the second one, take away the x from the first one. That would be 7 minus 1, or 6. Hey, that's what I got. 6 as my run. That's what I had my run as when I just counted. Okay. So really what this allows me to do is to say, okay, well, if I just know my endpoints, couldn't I find the difference in the rise and then find the difference in the run? And then I could calculate slope. Okay, and I absolutely can. Okay. Use the results from C and D to write a formula to describe how slope. No, I'm not going to do that. Okay, oh, sure. Okay, we'll write this little formula. Okay, slope equals, okay, my rise was like the difference in my y's, or my vertical coordinates, and my run was the difference in my run, or my horizontal coordinates, or my x values. Okay, so if I wanted to do that for like C, D, and E, and F, all right, CD, the slope of that one would be, so I'm going to go, the slope of CD, M, and then a little subscript, little letters, would be the y from the second one, so y from D, take away the y from the first one, and then x from D, take away the x from the second one. I'm finding the difference, and then it's just rise over run. Okay, well, let's find those values. C is the point 2, 5. And D is the point 6, 2. Okay, so y from D, that would be 2. Subtract the y from C would be 5. Okay, here's the y value from point D. Here's the y value from point C. Over the x value from D was 6. And then the other one was 2. So I get -3 over 4, or -3/4. If I count it out, 1, 2, 3 downwards, 1, 2, 3, 4 over. -3/4 is my slope. Okay. I could do the same thing for EF. I'm not going to do it. I think we want to start talking about the formula and actually jumping in. Okay. So here it is. Okay. Here's the slope formula. It says in mathematics, letter M is used to represent slope. Yeah, I already talked about that. If the graph of a linear relation passes through the points P and Q. Okay, so here's P, or kind of like my first X and my first Y. So X1, Y1. And then my first Q, X2, Y2. Okay, then the slope of the line can be written as Y2 minus Y1 over X2 minus X1. Or if you use the letters like we did before, Y from the second one minus Y from the first one over X from the second minus X from the first. Okay, we might use the kind of the letters, but normally I just deal with Y1, Y2, X1, X2. Okay, this is the slope formula. And what this allows me to do is, okay, number one, I don't need a picture of a graph anymore. As long as you tell me 2 coordinates, I'm good. And then there's also, what if I had a really, really, really big graph, right? And I didn't want to manually count all of those points. Well, that's what the formula is for. Okay, so this allows us to take it just kind of beyond manually counting and work with the formula. Okay, so the slope of a line, we're going to calculate from G to H. So it says the slope from G to H equals y from H minus y from G over x from H minus x from G. Or, okay, the formula is, okay, y2 minus y1 over x2 minus x1. That's typically what I'm going to plug into. Equals, okay? Well, let's actually label that. I label the point, I call one of them 0.1, one of them 0.2. So G, let's call that 0.1. I have x1 and I have y1, and I really get in the habit of labeling this so I don't mess up. The other one, that's 0.2, x2, y2. Okay, and it actually doesn't matter, right? I called this one the 0.1, this one 0.2. I could have switched that around and gone x2, y2, and then x1, y1. It doesn't matter as long as you keep your x's and y's together in the right way. But whatever. So this one I already labeled. Let's go with it. Okay, y2 minus y1. Well, that'd be -2 minus 8. -2 minus 8. I plug that in. Over, okay, x2 minus x1. So 7 minus -3. And notice I'm plugging in brackets. That's just going to help if I have any negatives. So on top, -2 minus 8 would be -10. You lost $2, you lost 8 more. 7 minus -3 is actually +10. I would add a line, change a sign, or type it into my calculator. And then you'd say, okay, well, -10 over 10, that's just -1. I always write things in the best possible way. If I have a fraction I can reduce, I reduce it. If I can just get a number, an integer, absolutely, this thing has a slope of -1. Okay, and that's the slope formula. Okay, I'll kind of highlight it up here. That's the one we're going to use. All right. It says Eleanor, Bonnie, and Carl are calculating the slope of a line segment with endpoints 15,8 and -10,6. Okay, their work is shown below. Since their answers are all different, at least 2 of the students have made errors in their calculations. Describe all the errors which have been made and determine the correct slope. Okay, I'm going to start this backwards actually. Okay, and what I'm going to do is find the slope first myself, and then I'll maybe go in and try to find the errors. Okay, so I'm going to write those points down again. It was 15,8 and -10,6. Okay, and I'm going to label. Okay, I'm going to call the first one x1, y1. Okay, x1 and y1 go together. The other one, x2, y2. I could have just as easily labeled these the opposite way, call this point 2, this point 1. It doesn't matter. Okay, now I write down the formula. Slope equals y2 minus y1 over x2 minus x1. Okay, which would equal, I'm going to work down just to maybe save some space. Y2, well, I labeled that as 6. Subtract y1, that's 8. Over, okay, x2 minus x1, -10. Oops, should have been putting these in brackets. Minus 15. Okay, for m equals 6 minus 8 is -2. -10 subtract 15 is -25. And then a negative divided by negative, well, that's a positive. It's 2/25. That's my slope. Then you say, okay, well, looking at all the answers, and I can see all their answers down below, none of them actually got it right. Okay, none of them got it right. So let's go through, and I have my answer and I have my work shown, and let's try to find some errors in what they did. Okay, and I'll talk about some specific things. Okay, Eleanor, -10 minus 15 over 6 minus 8. And you'd say, okay, well, they have the right numbers. They have the same things as me. But what they have is run over rise, which is no good. We need rise over run. So that was Eleanor's mistake. Okay. Bonnie, 6 minus 8. Oh, I have that. Okay, so that part's good. Over 15 minus -10. And you say, oh, wait a minute. That's not right. They have on top, they have y2 minus y1. But then on the bottom, they have x1 minus x2, which is the opposite. They flip those around. They switch that around. They got the wrong sign, got the wrong thing, and that's why I end up with such a bad situation. Okay, so no, that's no good. All right, Carl. Let's look at Carl. 8 minus 6 doesn't exactly look right, but I'd think about it, and you'd say, okay, well, I guess that's y1 minus y2. So you're finding the difference, but they just did the opposite order. And then 15, well, that's x1 minus, oh, it's supposed to be -10. He just said -10, but that point is actually supposed to be -10. So that's his mistake, okay? But Carl actually could have done it right. Let's say at the very start of this thing, I decided to label it the opposite way. I decided to call the first point x2 and y2. And then the next one, we call that x1, y1. Okay, it doesn't matter. I'm just naming the points. The points could have been given to me in any order. Okay, well, now let's try finding the slope. Okay, it would be y2 minus y1 over x2 minus x1 equals, in this case, it's 8 minus 6. That's what Carl has. Put that in brackets. over 15 minus negative 10. And then you say, okay, 8 minus 6, that's 2. 15 minus negative 10, well, that would be 15 plus 10, that's 25. Oh, I got the same slope. Okay, so the way Carl started of labeling your points the other way totally could have been fine. He just plugged in the wrong number. Okay, so there you go. That's the slope formula. I label my points, okay, label my points, and then I plug into the formula and I'm good to go. So this formula, you don't need to memorize. I would give that to you if it was ever an exam. For our situation, write it down, have it on the sheet with you when you go to do any of your assignments. I want you to have that formula. You don't need to memorize it. You can use it whenever you need. All right, let's use the slope formula. So this is, I guess, an application or an idea with the slope formula. And what it says is, okay, two lines in a plane. They can either be at an angle. So that's the first example. They kind of meet at a point. They can be parallel and distinct. So they're off on the side. They never touch each other. They never intersect. Or they could be parallel and form a straight line. So if I have from P to Q, I've got that point, and then I've got another line segment that just really continues the line. And if that's the case, they are said to be collinear. Okay, so P, Q, and R are collinear. They're all within the same line. From P to Q, and then Q to R, I'm all on the same line and go from there. And a way I can check if things are collinear is if their slopes are all the same. Okay, so for the example of P to Q to R, what that's saying is there are 3 slopes I need to check. If I want to know if these are all collinear, I check, okay, let me erase these colors. I check from P to Q, and you say, hey, what's the slope of this line? And then you say, okay, good. Now what about the kind of extension of it? Find the slope of that line. And then I check, okay, well, what about the whole thing connecting the endpoints? And if all 3 of those things have the same slope, they are considered collinear, or what we're saying is they're all in the same line. Okay, so consider the points 5, negative 3, 2, 6, and negative 7, 33. Are they collinear? Okay, what I'm going to do is calculate 3 slopes. I'm going to calculate the slope from A to B. I'm going to calculate the slope from B to C. And then I'm going to calculate the slope all the way from A to C. Okay, so for the first one, I'm dealing with 5, negative 3, and 2, 6. For the second one, I'm dealing with 2, 6, and negative 7, 33. And for the last one, I'm dealing with the kind of both ends, 5, negative 3, and negative 7, 33. Okay, I can think of A, B, and C. Are they in a straight line? And I'm going to calculate the individual slopes. Okay, but I'm only using ever 2 points. So as I go to do this, okay, what I'm going to do is go through and I'm going to label my x1, y1 for each section. So for the first slope, I'll call this x1, y1, and the other one x2, y2. And I'm going to solve this slope. Then when we go to the next one, I'm going to totally relabel and start again. Okay, so first one, slope equals y2 minus y1 over x2 minus x1 equals 6 minus negative 3 over 2 minus 5, which gives me 6 minus negative 3 would be positive 9 over 2 minus 5 is negative 3. And that would be negative 3. It's actually a whole number. Okay, there's my slope. All right, let's do that again. Next slope, let's calculate that. I'm relabeling. 2, 6, I'm going to call that x1, y1. Negative 70, 33, I'm going to call that x1, y1, or sorry, x2, y2. So I've labeled my x1, y1s, and now I plug into the formula. y2 minus y1 over x2 minus x1 equals, okay, well, negative 33 minus 6 over negative 7 minus 2 would be 33 minus 6 is 27. Negative 7 minus 2 is negative 9. That perfectly divides. I get a slope of negative 3. All right. So I'm thinking, hey, the first two have the same slope. If this big slope at the end has the same slope, I know these points are collinear. Okay, so I'm going to start. I need to label my points. First one, x1, y1. Next one, x2, y2. So I relabel. I am not going to write the formula because I don't think I have space, but I'll say y2 minus y1. 33 minus 5 over, and then on the bottom, x2 minus x1, so negative 5 minus 5, and that gives me, okay, 33 minus, oh, I totally wrote that wrong. Y2, there we go. 33 minus negative 3, y2 minus y1, good. Negative 7 minus 5, yeah, x2 minus x1. All right, I get negative, what do I get? 36. 33 minus negative 3 is 36. On the bottom, negative 7 minus 5 is negative 12. If I divide that out, I get negative 3. Okay, so prove that these points are collinear. I would say yes, they are collinear. Yes, they are collinear. So not something I would ever ask you to do often. I think I'll ask you to do in the homework. That's just something to keep in mind. If I'm asking, are these points collinear, I have to kind of connect all three of the slopes. The first segment, the next segment, and then the whole thing. And as long as they are all equal, they have the same slope, then they're considered collinear. Okay, last question for today. It says find the value of y if the point negative 4y lies on the line segment AC. Okay, so this is the line segment we just talked about. Okay, this is kind of a separate question. They connected it with this one, but this is something I would show you where it would give you some points, okay, with a missing value in one of them, and then it would give you a known slope, right? Because what I have is I've got this point negative 4 comma y, and if it lies on the line segment AC, I know its slope is negative 3, okay? And then I actually know a bunch. I know point A, point B, point C. Well, all I need to solve this question is one other point, so I'm going to pick the first one, 5, negative 3. Okay, so a normal question, yeah, it would probably give you this. It would say, hey, here's the information, find the missing value. Because it's already within the context, I know the slope is negative 3 because I found it above, and I just picked any of the points. I could just as easily pick this one or this one, and I still would get the same answer. Okay, it says find the value of y. Well, if I look at all of these things, I look at 2 points and I look at knowing the slope, I think of the slope formula. y2 minus y1 over x2 minus x1. That's what m is supposed to equal. And then I think, well, I have x1, y1. And then I have another point, so let's call that x2, y2. And then you have your slope. So if I plug all of that information in, okay, if I plug all that information in, I'm going to get negative 3 equals y2. Well, that was just y. That's the thing I'm going to find. Minus negative 3 over, and on the bottom, I'd have x2 minus x1. So negative 4 minus 5. I'm going to move my work up here so I have more space. Well, let's simplify. Negative 3 equals y minus negative 3, subtract a negative, that's just adding. That's really y plus 3. And on the bottom, you have -4 minus 5. That's -9. Great. This is an equation. I can solve this algebraically, right? I could say, hey, you have that whole thing divided by -9. The opposite of divided by -9 is multiply by -9. Okay. So -9 times -3, 27 equals y plus 3. And at this point, the opposite of add 3, subtract 3. There you go. 24 is equal to y. So we actually did that in yesterday's lesson, where we just used the slope formula of rise over run. And maybe I solved for rise, or maybe I decided for run. Here, it's a little more complicated. I use the real slope formula, and I can solve for a specific y piece or a specific x piece or whatever it's asking. Okay? And then there you go. That's our last question for today. So let's take a look at some homework. Page 532, 1, 2AC, 3AC, 5AB, 6A. And that is your homework that we're going to do for this lesson. And that is it for today. Looking at the slope formula and a little bit of homework for you guys to do, as well as a check for understanding today. So do the homework, ask your questions, set up a one-on-one appointment, all of that. Tune in again to the next video. And as always, smash the like button, hit subscribe. Tune in again tomorrow. Maybe I forgot one of my catch phrases, but that is it for today. Have a fantastic day.